Hello, dear students. Welcome back to your physics class. I'm Mr. Idris, physics teacher. If you remember, in a previous lesson, we studied how can you determine the direction of the induced current by the Lenz's law. In today's lesson, we will continue by explaining the Faraday's law, and we are going to solve all questions that are related with the Faraday's law to determine the induced current and induced EMF. Let's get started with the sample problem, and be with me with the full focus, please. Sample problem 6b, a coil with the 25 turns of wire is wrapped around the hollow tube with an area of 1.8 meters square. A coil with 25 turns. What do you mean by 25 turns? It means that this coil has 25 turns. Number of turns is given in the sample problem 6b. Number of turns is given and is equal to N is equal to 25 turns. Okay. Wrap it around the hollow tube with an area. The area of the tube is equal to 1.8 meters square. Each turn has the same area as the tube. It means that the tube is uniform. A uniform magnetic field is applied at a right angle to the plane of the coil. Guys, look. In this sample problem, mentioned that the angle between the applied magnetic field and the plane of the coil. If the plane of the loop or plane of the coil is right angle, it means that perpendicular to the applied field. If the plane of the loop is perpendicular to the applied field or to the magnetic field, it means that angle is 0. Why? Because we have to count the angle between the area vector and the magnetic field node plane of the loop. If the field increases, guys, look, if the field increases, where as I told you in the previous lesson, when delta B, change magnetic field, increases, it becomes what? Positive. Okay. When delta B is positive, EMF becomes what? Negative, according to Lenz's law. In this question, delta B or change in magnet, we have a change in magnetic field. It means that area is constant, but magnetic field is changing. Increases uniformly from 0 Tesla to 0.55 Tesla. B1, 0. B2, 0.55 Tesla. Okay, so in this sample problem, the magnetic field is changed. Okay, by changing magnetic field, can we induce electromotive force on the current? Yes, of course. Okay. In how many seconds? 0.85 seconds. Time is equal to what? 0.85 seconds. So it's very important to recognize the question. In the question, what is changes? Magnetic field area or the orientation of the angle. Okay, but in this sample problem, the magnetic field, the strength of the magnetic field is changed and also it increases, okay, or increases from 0 to 0.55 Tesla in 0.85 seconds. Find the magnitude of the induced EMF. What is unknown? EMF is unknown. If the resistance in the coil is 2.5, because the resistance is given, so that is why we have to find the induced current as well, okay? How we have two unknowns in this question, electromotive force and current. Now we will find the induced EMF by using Faraday's equation. Which equation can be used? Changing magnetic field or changing area? Absolutely by changing the magnetic field. Why? Because the magnetic field is changed in this question. And the magnetic field increases, so that is why it is positive. When delta B is positive, EMF and current must be negative. EMF is equal to negative N A cosine theta, change in magnetic field. Why? Because in this sample problem, the magnetic field is changed. EMF, do we have number of turns? Yes, 25 times area was given 1.8 cosine 0. Okay, times delta B is equal to what? B2 minus B1. Do we have B2? Yes, 0.55 minus 0 divided by 0.85. EMF is equal to what? Positive times negative is equal to negative. And by calculator, you can find out the value of electromotive force, which is equal to negative 29 volt. As I mentioned, here the electromotive force must be negative. Why? Because magnetic field increased. In the case when magnetic field increased, EMF and current must be negative. And how can you determine the amount of induced current? After you found the electromotive force, you have to replace into this equation to determine what? The amount of the induced current. EMF negative 29 divided by 2.5. I is equal to what? I is equal to negative 12 ampere. So in this way, you can determine electromotive force and the induced current. Look at practice 6b. Practice 6b. Question 1. A single circular loop. What do you mean by single circular loop? It means that number of turn is equal to 1. Number of turn is equal to what? 1. Okay. Number of turn is 1 with the radius r 22 centimeter. So you have to convert to meter is equal to 0.22 meter. Is placed in a uniform external magnetic field with the strength of 0.5 Tesla. B is equal to 0.5 Tesla. But we don't know this is B1 or B2. And now we don't know what is changes in this question, magnetic field or area. Okay, let's continue read the question. Strength of the magnetic field 0.5 Tesla so that the plane of the coil is perpendicular. If the plane of the coil or plane of the loop is perpendicular, angle is 0. Okay, how did you know angle is 0? Because the plane of the coil is perpendicular to the magnetic field. The coil is pulled steadily out. What do you mean by coils pulled steadily out? It means that the coil is moved out from this magnetic field. At first we have magnetic field, but when the coil is pulled steadily out, B2 becomes 0. B2 becomes what? 0. If B2 is 0, B1 is equal to what? 0.5 Tesla. Now in this case, what is changed? Magnetic field or area? Absolutely magnetic field. Guys, look, magnetic field decreased or increased? From 0.5 to 0, decreased. Magnetic field decreased, so that is why it is negative. When does delta B becomes negative? When magnetic field decreased, okay? Because according to Lenz's law, if delta B decreased and negative, EMF becomes what? Positive. Induced current, still positive, okay? Now, without solving question, we know that the final result of induced EMF and induced current must be positive. In how many seconds the coil was pulled out? In time 0.25 seconds. Find the average induced EMF during this interval. What is unknown? The average induced EMF. Guys, look, how can you determine EMF? So you have to write down the equation at first. What is changed here? Magnetic field. So we have to use this relation. Change in what? Area or magnetic field? Area. Magnetic field, sorry. Changing in what? Magnetic field divided by time. EMF, number of turn is 1. Area, guys, we don't have area, look. But instead of area, we have radius. The radius of the circle is given. If the radius is given, you can convert into the area by using this relation. Area is equal to what? Pi r square. 3.14 times 0.22 square. By using your calculator, you can find out, and instead of area, you can replace this number. 1 times, instead of area, write down what? 3.14 times 0.22 square times cosine 0 is equal to 1 times change magnetic field B2 minus B1. B2 is 0. 0 minus 0.5 divided by 0.25. EMF is equal to what? Negative 1 times 3.14 times 0.22 square times negative 0.5 divided 25. Negative with negative times negative is positive, and EMF, it should be positive and is equal to 0.3 volts. How did you know before solving the question? We knew that the EMF must be positive because delta B decreased. If delta B decreased, EMF and current becomes positive, okay? If delta B increases, induced EMF and induced current becomes negative. Question 2 in practice 6b, a coil with 205 turns. How many turns do we have? 205 turns. This is number of turns of a wire. A total resistance 23 ohm. Whenever the resistance is given, then you have to find the induced current because without the resistance we cannot find induced current. And the cross-section area of this coil is 0.25 meters square. 0.25 meters square is positioned with the plane perpendicular. Plane of the coil, plane of the loop. The plane of the loop is perpendicular to the field, means theta is 0. Okay? Of the powerful electromagnet, what average current is induced? What average current is induced in the coil during the 0.25 seconds? The time was given 0.25 seconds that the magnetic field drops. What do you mean by drop? Delta B drops, it means decreased. When delta B decreased, it becomes what? Negative. EMF positive, induced current positive. Drops from what? 1.6 to 0. B1, 1.6 Tesla. B2, 0. Delta B decreased or increased? Absolutely decreased. If delta B decreased, look, delta B here is negative. If delta B is negative, EMF positive, current is positive, okay? Now, how can you determine the induced current? First of all, you have to write down the equation of induced current, which is equal to EMF over resistance, okay? Do we have resistance? Yes. Do we have EMF? No. We have to find out EMF. What has changed? Magnetic field or area? Absolutely, magnetic field is changed. How did you know? Mentioned in the question, okay? In the question should be mentioned which one is changed, area or magnetic field. If the magnetic field is changed, so you have to use this relation, negative n, a cosine theta, change in magnetic field divided by time. Replace number of turns we have, area was given 0.25, cosine 0, 1, times change magnetic field B2, 0, minus 1.6, okay, divided by 0.25. Negative times negative is positive, okay? As I mentioned here, EMF and current must be positive. Positive what? 328 volts. In this question, we have to find induced current, not EMF. But without EMF, we cannot find out the induced current. How can you determine current? EMF over R. We didn't have EMF, but we found it. 328 divided by what? 23 is equal to positive what? 14 ampere. The induced current for this question is 14 ampere. Look at question 3, guys. Be with me, please. Question 3, a circular wire loop with the radius is given 0.33 meter. Sorry. 0.33 meter is located in an external magnetic field of strength 0.35 Tesla. B 0.35 Tesla. That is perpendicular to the plane of the loop. The magnetic field is perpendicular to the plane of the loop. If the magnetic field perpendicular to the plane of the loop, theta is 0. The field strength changes too. So it means that this is B1, B2, negative 0.25 Tesla. Guys, look, delta B in this question decreased. Okay, so the negative sign and this minus signs for the magnetic field refers to opposite direction through the coil. Delta B is negative. If delta B is negative, EMF is positive. Induced current is also positive. Okay. In how many seconds? 1.5 seconds. In 1.5 seconds, the magnetic field decreases from 0.35 to 0.25 Tesla. Okay. But don't forget, you have to write down this sign, and the sign, this minus signs for the magnetic field refers to the position, opposite direction through the coil. Find the magnitude of the average induced EMF during this time interval. EMF is unknown. Guys, look. How can you determine EMF? EMF is equal to negative N cosine theta, change magnetic field, change delta T. Negative, because number of turn is not given. The circular wire loop, it means that single loop, number of turn is 1. Number of turn is what? 1. Okay? Number of turn 1. Negative 1 times area. Guys, we don't have area, but instead of area, we have what? Radius. Whenever radius is given, so you have to convert to area. How? By using this relation, pi r square. 3.14 times, instead of area, write down what? 3.14 times 0.33 square times cosine 0 times change magnetic field. Look, guys, you have to put the sign. Okay, B2 negative 0.25 minus B1 0.35. Okay, so by calculator, negative 0.25 minus 0.35 is equal to negative 60 divided by what? Time 1.5. Negative times negative, it becomes what? Positive. Okay, so EMF is positive and is equal to 0.14 volts. Okay, guys, be careful. For the delta B in this question, delta B in this question, delta B over delta T is equal to what? B2 minus B1 over time. Do we have B2? Yes. Negative. Don't forget this negative, please. 0.25 minus 0.35 divided by what? 1.5 is equal to what? Negative, negative. It's still negative. 0.50, 0.60. Okay, divided by 1.5. The result of delta B becomes negative, and that is why EMF and current, it should be positive. Okay, this is question 3, and we finished the all questions of the practice 6B. Now we are going to solve the questions that related with the Faraday's law involves to determine the induced EMF and induced current in the Faraday's law. Question 10 in chapter review, in review assess. A question says a flexible loop of conducting wire has a radius. Question 10 in chapter review. Radius is given 0.12 meter and is perpendicular. The plane of the loop is perpendicular to the uniform magnetic field. Theta is 0. With the strength 0.15 Tesla. Magnetic field 0.15 Tesla. I don't know which one is changed in this question, area or magnetic field. Okay, as in figure, the figure is given, guys. The figure is given. If you look the figure, these two figures A and B, the magnetic field is constant. B1 is equal to B2, and magnetic field doesn't change. The magnetic field is constant. Okay, but the area of the loop is changed. The area of the loop is changed. How? Now I'm going to tell you. The loop is grasped at the opposite ends and stretch it until it closes to an area. So this is R1. We have to convert to A1 is equal to pi r square 3.14 times 0.12 square. Area is equal to 45 times 10 power negative 3 meters square. A1 is equal to what? Is equal to 45. The radius is given, but whenever the radius is given, you can convert to area. 45 times 10 power negative 3 meters square. How about A2? A2 is equal to what? The area is changed after grasped at the end, at the opposite ends of the circle. The area of the circular loop is decreased to 3 times 10 power negative 3 meters square. This is A1, and A2 is equal to what? 3 times 10 power negative 3 meters square. Now, between these two areas, because delta A decreased, so that is why it becomes negative, but EMF is positive, induced current is positive. Why? Because when area decreased, A becomes negative, but EMF positive, induced current is still positive. Okay? As in the figure below, if it takes 0.2 seconds, the time that takes to decrease this area of the loop is equal to 0.2 seconds. 0.2 seconds. This is the time takes to decrease the area of this loop from 45 times 10 power negative 3 to 3 times 10 power negative 3. To the closed loop, find the magnitude of the average EMF induced in the loop during this time. EMF is unknown. Okay, how can you determine EMF? At first, you have to make sure which one is changed, magnetic field or area. In this question, guys, be careful. In question 10, review and assess. The area of the coil is changed. So that is why we have to use the second equation of Faraday's law, negative N B cosine theta. Delta A or delta B? Absolutely delta A. Why? Because area is changed to delta, divided by delta T. Bring down the number of the loop is 1, negative 1, times magnetic field is constant, fix it, 0.15, cosine 0, delta A is equal to A2 minus A1. A2, 3 times 10 power negative 3 minus 45 times 10 power negative 3 divided by what? 0.2. Okay, this negative times negative becomes positive, and EMF is positive and is equal to 3.2 times 10 power negative 2 volt. This is the induced EMF that induced or created in this coil after the area of the coil decreased from 45 times 10 power negative 3 meters square to 3 times 10 power negative 3 meters square. Question 11. In review and assess, question 11. The question says a rectangular coil. A rectangular coil, what do you mean by this? It means that the shape of the coil is rectangular. It is length 0.085 meter. It is width is 0.055 meter. Okay, length 0.085 meter, width 0.055 meter. So by giving length and width, you can determine area. Area of rectangle is equal to length times width. 0.085 times 0.055. Area is equal to what? 0.004675 meter square. Now, do we have area? Yes, we have area. Okay. If the length and the width is given for the coil, so you have to convert the length and the width in order to find the area of the rectangle. The area of the rectangle is equal to length times width. The cross-section area is perpendicular to the direction of the magnetic field. It means that the plane of the loop is perpendicular to the direction of the magnetic field. So that is why theta is equal to 0. And if the coil has 75 turns, number of turns is equal to what? 75 turns. And the total resistance, whenever the resistance is given in the question, you have to convert the current, because without resistance we cannot determine the amount of the current. The resistance 8.7 ohm, and the field decreases. Guys, look, what happens to the field? Decreases. When field decreases, delta B is positive or negative? Absolutely is negative. When delta B is negative, EMF is positive, induced current is positive, as you can see here. Without solving question, you have to know what will be the final answer for the induced current and induced EMF. Is it positive or negative? Okay, because of the Lenz's law. The magnetic field decreases at a rate. A rate, what do you mean by rate? Delta B over delta T. Delta B over delta T. Guys, look. Delta B over delta T is equal to what? How did you know this is delta B over delta T? Because Tesla per second. Tesla per second. We have what? Tesla per second is equal to 3. But this 3 should be negative. Why? Because magnetic field decreased. How did you know this 3 must be negative? Because mentioned in the question, delta field is decreased. If delta B decreased, EMF and induced current is positive. What will be the magnet of the induced current in the coil? What is unknown? Induced current. I is equal to what? EMF over R. But we don't have EMF. EMF is equal to what? Change magnetic field or change current? Magnetic field changed, decreased by a rate 3 Tesla per second, which is equal to negative 3 Tesla per second because it is decreased. Negative N A cosine theta delta B over delta T. Guys, look. EMF is equal to what? Negative 75 area. We didn't have area, but we found 0.004675 cosine 0.1 times. Do we have delta B? No, but we have the rate of the change in magnetic field. Okay, the time rate of the changing of the magnetic field. Delta B over delta T together given is equal to negative 3. Okay, negative 3. Instead of delta B over delta T, write down negative 3, just negative 3. Negative times negative is positive, so EMF is positive what? 1.05 volts. In the question, we have to find what? Induced current. We didn't have EMF, but we found 105 divided by what? 8.7. The amount of the induced current that created in this coil is equal to 0.12 ampere. 0.12 what? Ampere. The induced current. Guys, question 12. Okay. We are continuing to solve all questions that related with the Faraday's law to determine the induced EMF and induced current and the other variables. 52 turns, question 12. Number of turn 52. Coil with an area is given of 5.5 times 10 power negative 3 Tesla, meter square. Okay, is dropped. Guys, if you see dropped, it means that this coil, this area is dropped from a place without magnetic field to the place with a magnetic field. Okay, by dropping the coil into the magnetic field, always B1 is equal to 0. B1 is equal to what? 0. Why? Because the coil is dropped. How did you know B1 is 0? Because the area and the coil is dropped from a position where magnetic field is 0. Okay? Dropped from and also was mentioned here, dropped from a position where magnetic field is 0. But if the question says dropped from a position where the magnetic field is equal to something, in this case, B1 is not equal to 0. Be careful. Okay? When does B1 is equal to 0? If the question says the coil is dropped from a position without magnetic field or magnetic field is 0 to a new position where B is 0.55. B2 0.55 Tesla. Look, so this is area changed or magnetic field? Absolutely magnetic field changed. Decreased or increased? Of course, increased from 0 to 0.55. If delta B increased, delta B becomes what? Positive. How about induced current and EMF? Negative. EMF and induced current becomes negative. Look, negative. In how many seconds this process will occur? And occurred in 0.25 seconds. In how many seconds? 0.25 seconds. And the area of the coil is perpendicular angle. The area of the coil, the plane of the coil is the same thing, okay? What is the resulting average EMF induced in the coil? What is unknown? Average EMF induced in the coil is unknown. To determine the induced EMF, you have to use the Faraday's equation, negative N A cosine theta. What is changed here? B. Magnetic field is changed. We have delta B over delta T. EMF, number of turn, 52. Area, 5.5 times 10 power negative 3. Cosine 0. Delta B, 0.55 minus 0 divided by 0.25 positive times negative, it becomes negative. Negative what? 0.63 volt. By calculator, you can get the final result of induced EMF in this question, question 12. Question 46, guys, look. In question number 46 in review and assess, a student attempts to make a simple generator by passing a single loop. What do you mean by single loop? Question 46. Number of loop is equal to 1 of a wire between the poles of the horseshoe magnet with 2.5 times 10 power negative 2 Tesla. This is B, but I don't know this is B1 or B2, okay, or maybe B is constant, okay, it depends on the question. 2.5 times 10 power negative 2 Tesla. Okay, the area of the loop, we have area of the loop is equal to 7.54 times 10 power negative 3 meters square, and is moved perpendicular to the magnetic field. The area of the coil, the plane of the coil is moved perpendicular, which means angle is equal to 0. Okay. In what time interval would the student have to move the loop out of the magnetic field? In what time? What do you mean by in what time? Time is unknown. In what, guys, listen carefully, please. In what time interval? It means that time is unknown. Will the student have to move what? The loop out of the magnetic field. Out of the magnetic field, it means that the coil is pulled steadily out. The coil exists into the magnetic field. So that is why B2 is equal to 0. When does B2 is equal to 0? When the coil is pulled steadily out, when the coil is moved out from the magnetic field, when the coil exists from the magnetic field. In all these situations that I mentioned, B2 is equal to 0. In order to induce EMF 1.5 volt. So is this practical generator? So if this one B2, this one becomes B1. Guys, look, between B2 and B1, B1 2.5, B2 0. Delta B decreased or increased? Absolutely, delta B decreased. When delta B decreased, EMF, delta B is negative, but EMF, it should be what? Positive. Look, EMF was given in positive. But if the question, but in the same question, but when the magnetic field is dropped from a region with the 0 magnetic field to the region with the, like, for example, more magnetic field, in this case, the EMF must be negative. Okay? Why EMF is positive here? Because magnetic field decreased. But how about if the magnetic field increased? If the magnetic field increased, guys, pay attention, please. If the magnetic field increased, this EMF should be negative. Okay? Now, let's find delta T. What is changed? Magnetic field is changed. EMF N cosine theta B over T. And also you can rearrange this equation like this, negative NA cosine theta delta B over what? Delta T. What is unknown? Delta T. Rearrange the equation. Okay. Delta T is equal to what? Negative NA cosine 0 delta B. Delta B is equal to what? B2 minus B1 over what? EMF. Delta T is equal to, number of turn is 1, area was given 7.54 times 10 power negative 3 times cosine 0, 1 times magnetic field B2, 0 minus 2.5 times 10 power negative 2 Tesla divided by what? Positive 1.5. Okay, so negative times negative is positive, positive divided by positive. Delta T is positive. Time is always must be positive because it is forward always, and is equal to 1.3. 1.3 times 10 power negative 4 second. So that is why this simple generator is not practical, because the time is very small and the time is too short. The time that takes to move and to pull out the coil into the magnetic field is too short. So that is why this simple generator is not a practical generator. Guys, the last question in the Faraday's law to determine the magnitude of induced EMF and induced current. A question says a coil of 325 turns. Question number 47. Number of turn is equal to what? 325 turns. Okay. This is number of turn and an area 19.5 times 10 power negative 4 meters square. Okay. Is removed from a uniform magnetic field. Whenever the coil is removed from uniform magnetic field, B2 is 0. When does B2 is 0? When the coil is pulled steadily out, moved out, and coil is removed from uniform magnetic field at an angle 45 degree. The angle is 45 degree in time 1.25 second. Okay, a coil of 35 turns and an area is removed from, because the area is removed from the coil, so that is why if the angle is not 45, likewise if the angle is 40 or 35 degree, then you have to convert this angle. Okay, how? If this angle is 30 degree, okay, theta, it should be what? 90 minus 30. 90 minus 30 is equal to what is, so you have to count this 60 degree. Okay, because the coil is removed, the plane of the loop is removed with this angle. Okay, 45 minus 90 minus 45, it's still 45. Okay, in how many seconds? Time of 1.25 seconds. If the induced EMF is is equal to what? 15 millivolt. You have to convert to volt. 15 times 10 power negative 3 volt. But guys, this EMF is positive or negative, and why? Look at the question. Because the coil is removed, B final is 0. B2 is 0. When B2 is 0, it means that B1, in this case, B1 is bigger than B2. When B1 is bigger than B2, okay, delta B decreased. When delta B decreased, delta B becomes negative. EMF is positive, current is positive. Okay, so that is why this EMF, it should be positive. Why? Because delta B magnetic field decreased. What is unknown? What is the magnetic field strength? Initial magnetic field is unknown. What is unknown? Initial magnetic field. Initial magnetic field is equal to what? Sorry, delta B is equal to what? B2 or B final minus B initial, or B2 minus B1, okay? B1 is unknown. B2 minus B1. So do we have B2? Yes, it's 0. Now we have to find delta B. After finding delta B, you have to replace into this equation to determine what? B1. Look, how can you determine delta B? By using this relation, negative NA cosine theta delta B over delta T. Okay, delta B is equal to what? Rearrange the equation, EMF times delta T. Sorry. EMF times delta T, it goes up, and negative NA cosine 45, it goes down. Delta B is equal to what? By using calculator, you can determine the amount of delta B. Look. EMF, replace number. EMF, positive 15 times 10 power negative 3 times 1.25 divided by negative N is equal to 325 times area 19.5 times 10 power negative 4 divided by cosine 45 is equal to 0.7. Delta B is equal to what? By using your calculator, 15 times 1.25, shift log 10 power negative 3. Okay, I got this number, 0.01875, divided by, open bracket, negative 325 times 19.5 times shift log negative 4. Okay, and the time is 0.7. I got negative 0.042, negative 0.0442 Tesla. What is this? This is change in magnetic field, guys. As I mentioned here, change in magnetic field, it should be negative. Okay, so I got negative. Why? Because magnetic field decreased, because the coil is removed from the coil. Delta B is negative. Now we have to find B1. How can I rearrange B1? B1 is equal to what? B1 is equal to B2 minus delta B. Okay, B1 is equal to B2 0 minus delta B negative 0.042. B1 is equal to what? Positive 0.042 Tesla. Okay, B1 is equal to what? 0.0 B1 0.042 Tesla, or 4.2 scientific notation 10 power negative 2 Tesla is the same thing. It doesn't matter. Okay, no matter in the scientific notation or like this in a decimal, both are correct. And so this is classroom practice. You have to solve by yourself. Okay, if you don't understand this question, or if you are struggling with this question, you can leave this question in the comment, and I will answer as soon as possible, inshallah. Okay, guys, that's all for today. Inshallah, in the next lesson, we will continue by explaining the section 1 in chapter 6 about the self-induction. Okay, the last two topics remain or left in this section: self-induction and eddy current. Thanks for listening, and keep up your best doing.